Hello guys. So for today, I actually wanted to discuss further about database indexing, and particularly this time since for the last few days or whatever sessions I had, we were mostly talking about concepts which were purely theoretical. There were no evidences, and I just wanted to try it myself because whatever the amount of theoretical knowledge we gather, we are not able to actually articulate our thoughts around it and explain it to others clearly. So, of course, as usual, I love the content created by Hussein Nasser and a big fan of him, honestly, because the way he teaches you something, it's unmatchable, I think. I haven't found any better explanation, honestly, about the explain and analyze statements, how the index scan works, how the index only scan works, and even some of my misconceptions about how the databases actually work were actually corrected by a recent lesson I actually had just taken a go. I'm taking a course from Udemy about the database engineering, understanding more about how databases work. Because honestly, I'm kind of a you can call me a maniac because I was asked a question about how you will analyze the performance database is having, and I had no answer for it. So I decided that I will try my best to find out how it actually works. And again, if anyone ever tries to question me about how I will analyze the database performance, I have, more than 20 to even 30 reasons how would I actually do it. So let's just um, dive quickly into what we are going to discuss today. So, sorry, I'm using Excalibur here because I am not able to demo it live because of the capability and the performance issue on my machine. I have to record on one machine and try to play with it on the another machine, which is a Linux machine. So usually what happens is an application or database, whatever it is, Postgres or any other relational databases, even non-relational databases as well. When we try to fetch something, we first of all the database actually goes to the RAM, random access memory. You know why? Because it's fast and it's much closer to your programs where they are being executed. It actually goes to the operating system level concepts that why we go to the RAM is because RAM is closer to it, like just like the caches L1, L2, L3, and so on, and then the RAM. So that is why the first instinct by the database is actually go to the RAM and check if things are there. If not, only then they actually go to the disk, which is slow. It is quite slow as compared to caches and the RAM. Okay, so we only go to that place if we do not find things in the RAM. Because, of course, everything in the operating system is designed around efficiency. This was actually the first query. This database had actually 15 million rows. So it's quite large, honestly. On my 16 gig memory machine of Core i7, it took around about 2 minutes, which was honestly quite awkward for me. But anyway, so we have a statement explain, analyze, select ID and G from students where G is greater than 8 and G is less than 95. We are ordering them by descending order, the G value. Now, actually, this query was between 80 and 95, but by mistake, I just did it and turned out that even though G has an index on it, the result is actually a gather merge. It's not a index scan. We are not using index. We are using simply the parallel sequential scan, as you can see here. So we are using sequential scan. And the number of rows we have removed are probably these are 23 million rows almost. It's quite a large number. And the values here like cost. So the initial cost is also too much high. It's taking quite a lot of time to even initialize things, check for things, and then um, it has just an estimation that this would actually end like 89 seconds. Probably it's 89 minutes, I think. But anyway, there are many rows here, 43 million rows with all these things. Yeah. And the width height actually represents how much bytes we have. So since ID and G both are integers, each takes 4 bytes. That is why we have width as um, 2 bytes. Sorry, 8 bytes. So as you can see, it took quite a long time, 33 seconds. It's quite slow, honestly. Um, Then what I tried actually another query, but this time I have applied a limit on it. Okay. I will actually explain also why it is actually taking a sequential scan, even though there is an index on it. Now, what I used to think that if there's an index on your particular property or value, it will always go to the RAM or the index in the RAM, and then or it will actually fetch the index into the RAM and then read from it. Then only will go to the disk. But it does not work like that, and it was shocking for me. By chance, but I got shocked about it that if it finds the query planner finds that you can spend less time using parallel sequential scan, like just go into the disk and start um, getting pages back into RAM and processing them instead of reading index then going there. It takes a lot of time. So that is why it chose parallel sequential scan for this large number of rows instead of using index scan. The second statement uses limit. Now we are limiting the number of values which we are going to retrieve. Again, the rows removed by filter are still 23 million almost. And but the time taken is almost to half. So we are taking almost 16 seconds, which is still quite large value, honestly, in case of a database. If you are working with a production database, this is catastrophic. I cannot believe that your query will be delayed by 16 seconds. You usually would like, what the can't say that, but like what the hell I'm doing here sitting. So that it is something not good. After indexing G, so it was already indexed, but I thought that it was not indexed, and that is why I wrote this thing. But still, it is using the parent sequential scan. Again, the reason is very clear that the range is very large from 8 to 95. Actually, total value lie actually between 0 and 100. So you can imagine that we are almost using all the records and trying to fetch them. That is why it is using parallel sequential scan. Now what we did is we again, now this time I think it is a similar one, but I have taken the wrong query for it, probably because this time this was not the correct one. I believe I had taken value 10 and 20. That is why this time it is actually using index scan instead of parallel sequential scan. And the reason is simple. Because no, I think no, not like that. This was indexed. Sorry, sorry for that. It was indexed. That is why and because we have applied limit 1000 and now it is actually indexed is using index scan. And we have limited the value to 1000. That is why now it is actually using index scan. Index scan means it will fetch the index into the RAM, then it will read those values. Okay, and for each row, it will actually move to the disk, take that page, retrieve the content. That is how index scan works. It is still going to disk. It doesn't mean that we have lesser, we are not going to the disk. It is still slow, but again, there's a quite gap jump from 16 seconds to 4 seconds, as you can see. And okay, so we have fetch on, yeah, 1000 rows. Now the second one, this one would be again much faster than that. Still, we are taking values between 10 and 20,000 results, and again the values, the execution time is between 4.074 millisecond, almost a 4 seconds. Then we are actually again got because I tried it again. I was confused by why the hell it is not using index scan. I tried it again, and it was again a parallel sequential scan, even though we had applied index on G, the value G. But it is still using parallel sequential scan. As you can see, if we apply the limit, since there are lesser values now, the window of values is actually squeezed down to only 1000 values. That is why the query plan decides that using index scan is quite fast compared to using no indexes. Okay, so let's move to another query. Now there is an interesting thing. This is again we are using a new query, values ranging between 10 and 20. Again, we are ordering the value g by descending order, and as you can see, it is still, even though the range is small, but it still choose to perform parallel sequential scan, and the number of rows here are actually 15 million, quite large. Okay, let's try something else. So there was one more concept which I wanted to actually discuss here, which I read recently. That was covering indexes. So what are covering indexes? Covering indexes are you actually store a non-key column. Okay, first ID is actually a key, primary key. Okay, while there is a non-key column like maybe G, it's a non-key. It is not a primary key or any another key like composite or whatever. So it's a non-key column, and um, we are actually going to create an index on both of these. Okay, the ID and the G. So what will happen is when this we try to do this, now when we try to select ID and G, it will apply the index only scan that is different from index scan. So index scan still goes to the disk, while the index only scan, once it has fetched the pages into the memory, it will not go to the disk. Why? Because the value G is stored along with the index, the value ID. That is why you are not going to the disk again. You're just fetching the things into RAM and you can directly access the value G from there. And that is why, as you can see here, it is written clearly index only scan. Okay. So we are still only using index only scan. It is different from index scan. There you still go to the disk to fetch the value from the disk because it's not stored along with the index. So there is a difference between a simple index and a covering index. Okay, it's different from composite index actually. I will explain it sometime afterwards. So, and again, we can see we have value between 10 and 20, and we are applying limit because the values are quite large. So it is indexes only scan, and um, there is a difference between time. Here, execution time is 3.2, almost 3 seconds. But while here, execution time is 0.463 millisecond. Why is that? It's the same query. So what happened is we have a statement to run, which is a vacuuming. I have no clear concept about it. I will read more about it and maybe then share with you. But I have read is that vacuum actually clears it actually improves the visibility map, which Query Planner uses to make sure that there are no duplicate records or uncommitted stuff in the disk. So maybe they may contain values which we are trying to retrieve here directly from the RAM instead of disk. So if you have not applied vacuum after you're running the vacuum on your whole database, the difference can be quite drastic. As you can see, it's almost around about 7 times, 7 times 428. Yeah, it's almost around 7 times improvement. So on it, honestly, it's quite an improvement. So yeah, for today, I just wanted to discuss these things because honestly, a lot of people usually discuss on platforms like LinkedIn and even Substack, X that you should be knowing about, explain and analyze. But how does they actually work, and how can you use them for your advantage and learn about the database performance? So that was all for today, and I think you actually learned something new from this. And have a good day. Goodbye.